Welcome to GIS Gallery. In this tutorial, I'll show you how to calculate the mean total rainfall for Madhya Pradesh using rainfall point data and the Thiessen Polygon, or Voronoi Polygon, method in QGIS. This method helps to estimate rainfall distribution by creating polygons based on point data, assigning each area the rainfall value of the nearest station. Let's get started with this effective spatial analysis technique.
So in this class, we will be seeing how you can process rainfall data. First of all, we'll be starting with creating Thiessen Polygon and finding out annual rainfall. As well as we'll be also using looking at interpolation methods, preferably IDW. So do you remember how we did it in IGIS? How we created the Thiessen Polygon? So if you remember, we will be first creating Thiessen polygons like this, and then using these polygons, we will be looking at after we have created the polygons, we'll be using this equation, right? Sum of area into rainfall data given by total area. Alright. So for that, first we need is the rainfall data points, right? I believe you remember how we did in RGS. So first, and then we need the Madhya Pradesh boundary also. So for that, I have got the boundary for India. From this, I'll be extracting the Madhya Pradesh boundary. So I have selected this one. I go to export, and then I'll click on save selected features as, and then I'll give the name here. Alright. I'll set the location also. So I have extracted the Madhya Pradesh boundary. Now if you see here, both these data are in. So if you come to the information here, you can say that it's in QGIS 84 corner system. Okay. For a measurement and calculation, we'll need to project it into project to corner system. That is UTM, right? So for that, I have to first project both of these into UTM. So I'll go to vector in geometry tools. Now in the data management tools, I have reproject level. Okay. I'll first project my MP points. Target CRS will be UTM zone 43 north, and I'll also set the save location. I'll save the file as MP point species. Okay, I will just clear on this. Okay, and then when it has been projected and a new point has been created. Similarly, I'll be projecting my boundary file also. It will be the management free project player. I'll set on the MP boundary, and then target CRS will set as UTM zone 43 north. And then I'll be setting my file location. I'll set on save to file, and I'll click on MP boundary TCS name. I'll override this file. Click OK. Run. Now both these have been projected into UTM zone. Now what I'll need to do is I'll have to first create a Thiessen Polygon. Okay. For creating Thiessen Polygon, if you come to vector, geometry tools, you have Voronoi Polygons. Okay, in QGIS, Thiessen Polygon is also called Voronoi Polygons. I click on Voronoi Polygons, and the input layer will be my projected Madhya Pradesh rainfall data. Okay, so I'll click on that, and I'll set a buffer region so that this point, right? So these points, the polygons will be created out towards these points, so that when I click this boundary, it will have data for everyone. Okay. So I'll see you. So if you set that, I can, it's in percentage of extent. So I can give something like 5 or 6 extent. And then I'll also set the save file. I'll just do the same way, overwrite it, and I run it. You can say that it has been created. So if we set the layer, you can see this thing, right? So this is what I meant by the percentage of extent, the buffer. So it has been created outward the boundary. Okay, so now I can easily flip this file. Okay, so that I just need this polygons only for inside this boundary. So for flipping, I'll go to vector, geo processing, and then click on flip. So the input layer will be the Thiessen Polygons, and then overlay will be my MP boundary TCS. Alright. Then I'll save the file and give the name Thiessen MP. Replace it and I'll just call. Now you can see that it has been clicked. Now if you come over here, we know that to find out the average rainfall data, we'll have to first on area and then find out the total area. As well also, we'll have to calculate area into rainfall divided by total area calculation. Alright. For that, I'll just go to my attribute table of the table. And in here, I'll be creating a field for area. So I'll be opening calculator. I'll be setting the name area. Output field type will be decimal number. And in here, I'll be finding the area. So finding area, you have to come under geometry, click on area, and then I'll just click OK. But you have to understand that by default, it will be in meter squares, okay, area. So if you want to change it, you'll have to go to project and then change it. So I'll just convert it directly from here. Now it's in square kilometer, okay. I click OK. Area has been calculated. Now I have to find out what is the sum total of this area so that I can use it in my next calculation. So if you come over here, we have the show statistical summary. Click on show statistical summary. The statistics panel has been opened. In here, I'll select my Thiessen MP, and in here I have the area field. And now, if you see, it has been calculating the statistic summary for all my area. So if I come over to sum, I have the sum here. So I could just copy this and then create a new node or something so that I could paste it. And then from here, I'll be copying my sum. Okay, I'll be copying my sum. Now I'll just come over here. Alright. Okay. Now I'll be opening my field calculator again, and then I'll be setting my equation here. So my equation was from the fields I can select the fields. The equation was rainfall area into rainfall and then divide by the total area which I just copied. So I'll just paste it here and I'll click OK. Now you can see that rainfall has been calculated. From this, I have to find out the sum total because that is given here, right? I have to find out the sum of the area into precipitation by total area. For that, similarly, I'll be going to show statistical summary, right? I'll click on Thiessen MP and find out the drop down and click on main. Now we have the sum here, which is your main annual rainfall data. Okay. So this is how you can do your Thiessen Polygon and find out the rainfall.